Okay. Well, good morning, ladies and gentlemen. And if you guys want to join me, I'm on the meet, but it is the 2018 FRQs. We're going to be working on questions 1 and 2, the ones that require a calculator. And even though we have 30 minutes for this, the video might be shorter or it might be longer. It just depends because my goal is not just to solve it, but like talk about it, break it down, uh, remind you of concepts and formulas along the way. So everything I do and I write is not necessarily what you have to show on on the questions. And I'll tell you what it will be. So question number 1. Okay, we have a table here and it says that G of t is cubic feet per minute. Grain is being added to the silo and at 0, the silo is empty. Okay. Use the data in the table and approximate the G prime of 3. Using the correct units, interpret the meaning of G prime of 3. In order for us to approximate G prime of 3, which is the slope of G of t, we're going to be using the two closest points. We're going to be using 1 and 5 to find the slope here. So G prime of 3 is going to be given by G of 5 minus G of 1 divided by 5 minus 1. So in other words, just your average rate of change. G of 5 is 20.5 minus 15.1 divided by 4. This gives us 5.4 divided by 4. And 5.4 divided by 4, that's going to be 1.35. Yep. So that's the value, and you're going to get 1 point for getting this correct. And then the second point by interpreting the function. So at t is equal to 3 minutes, the rate at which grain is being added to the silo is increasing because our answer was positive. At a rate of 1.35 cubic feet per minute, or you can say per minute squared. That's because it was a derivative. G of t was already a derivative. Even though it didn't have the prime symbol, don't confuse it, right? Like the units tell you that it's a derivative. B. Write an integral expression that represents the total amount of grain added. Okay. So just by writing the integral expression from 0 to 8 of G of t dt, just this little piece alone already gets you 1 point. One of the biggest mistakes I saw was people were confusing the integral setup with the right Riemann sum setup. A right Riemann sum is basically just a bunch of rectangles being added, 4 of them. So it's base times height plus base times height plus base times height plus base times height. Now, some students did the integral from 0 to 8 of base times height plus base times height. That right there is wrong, because both the integral and the rectangles, they're both calculated in area. By putting an integral on top of the base times heights, you're saying you want to calculate the area of the area. That makes no sense. So the integral will become the base times height plus the base times height plus the base times height. Okay. So if you look at your table, the first base goes from 1 to 0, so you're going to subtract them. And for the height, you can either select G of 0 or G of 1, but we have to select the right value. And the right value is 15.1. On the second rectangle, the base is going to be found by doing 5 minus 1. And the height is the right value, so 20.5. Then the next base is going to be 6 minus 5 with a height of 18.3. And finally, the last base, oh, really careful on the AP test. don't write past this line. It even tells you right here, but my thing got cut off. So don't write past those lines because there's no guarantee that's going to be graded. So I'm just going to scoot this over. Okay. The final rectangle is going to have a base of 8 minus 6 with a height of 22.7. So that's 15.1. Oh, and you have a calculator for this question, right? So this, you should not be getting this wrong. So I'm actually going to skip the work by hand, and I'm just going to tell you the answer. We have 160.8. So 160.8 cubic feet of grain is added to the silo during the first 8 minutes. Now, going back to the question, it says that you want to do an integral that represents the total amount of grain added. You could technically put the absolute value of g of t, but the reason that I didn't is because g of t already represents grain added. So automatically it's already positive. But putting the absolute value is not going to be wrong here. C. Grain in the silo is spoiling at a rate modeled by W of t, where W of t is measured in cubic feet per minute. Using the result in part B, approximate the amount of unspoiled grain. Okay. So if you want to find your unspoiled grain, you need to take into account the grain that was added, and you need to subtract the spoiled grain. So the grain that was added is going to be the integral from 0 to 8 of g of t dt, which we already found in part B, minus the integral from 0 to 8 of wt dt. This is 160.8, and then the value of the second integral, you're going to find it by taking your calculator and using math 9. You should not be trying to take derivatives or integrals by hand, especially if you have a calculator. So this is 99.055, which gives us 61.749 cubic feet of unspoiled grain. Okay. Part D, based on this model, or the model in part C, is the amount of unspoiled grain increasing or decreasing? Well, anytime they ask you about something, about if something is increasing or decreasing, you need to find a derivative. So your unspoiled grain is going to be given by the grain that you're adding, right? Grain added, and we're going to be subtracting the spoiled grain. So is the amount of unspoiled grain in the silo increasing or decreasing? Well, the grain being added is represented by g of t, and the spoiled grain is w of t. But these are already rates, right? So technically, we don't even have to derive. We just have to figure out what g of 6 is and w of 6 gives. That's going to give us, plug it into the calculator. That's going to give us 16.06. No, I think this answer is that what it gives us? Let me take a look real quick. Part D. Yeah, no, it's because I had a different calculation here. 16.606 was the W of 6. The actual difference is 2.237. And this technically is a derivative, right? Because these are rates. These are rates. That is my unspoiled grain, the derivative of the unspoiled grain. So, because G of 6 minus W of 6 is a positive value, the amount of unspoiled grain is increasing at t is equal to 6 minutes. You don't even have to subtract them. You can just get the value of G of 6 and W of 6 and just compare the values to check which one is greater. And I mean, you're going to come to the same conclusion. We're adding more grain than grain is spoiling. So the amount of unspoiled grain should be increasing. Okay. 2. A snail is traveling along a straight path, and we're given the velocity. Find the acceleration. Okay. This is a really easy question because we have a calculator. If you want to find the acceleration, all you got to do is use math 8 at t is equal to 5. And just give the answer. A of 5 equals 0.538. And put the units just in case. The velocity is given in inches per minute, so the acceleration is going to be inches per minute squared. You know what? I'll even give a sentence just in case. The acceleration of the snail at t is equal to 5 is 0.538 inches per minute squared. B. What is the displacement? In other words, what was the net change? That's what a displacement is. It's net change. And in this case, it's the distance the snail traveled, but not the total distance. It's just the displacement from where it started to where it currently is. So we're going to do the integral from 0 to 15 of v of t dt. Again, all calculator work. This gives us 76.043 inches traveled during the first 15 minutes. Part C. At what time is the snail's instantaneous velocity equal to the average velocity? This part is talking technically about the mean value theorem. When the derivative is equal to the average rate of change. So S of 15 divided by S of 0 divided by 15 minus 0. The only tricky thing about this part right now is that we don't have a position function. So the way we're going to get S of 15 minus S of 0 is by doing average value. So it's going to be 1 over b minus a times the integral from a to v of the velocity. And think about it this way. If you integrate velocity, we're going to get position. That's how this formula converts into this formula. 1 over 15 times the integral from 0 to 15 of v of t dt. That gives us 5.07. So take your instantaneous velocity and make it equal to the average velocity. Now, you're going to use your calculator for this. I would recommend for you to subtract the 5.07 and make it equal to 0. Graph your function and find the x-intercepts. And the x-intercepts are going to be 6.031 minutes. The last part. An ant arrives at the snail's starting position at 12 minutes and it follows the snail's path. During the interval from 12 to 15, the ant travels in the same direction as the snail with a constant acceleration of 2 inches per minute. And then the ant catches up to the snail at 15 minutes. So basically 3 minutes later. The ant's velocity is at 12 is b. Find the value of b. Okay, this is kind of a tricky question, but okay, the ant has an acceleration of 2 inches per minute, which means the velocity of the ant is going to be 2t plus c. Now, do I know an initial condition to find this? I do not. But I know this is part of my velocity equation. So, distance traveled by the ant is going to be the integral from 12 to 15 of 2t plus c dt. And that should equal the distance traveled by the snail, which is the integral from 0 to 15 of v of t dt. We already know what the velocity is for the snail. And I'm setting these equal to each other because they have both traveled the same amount. It just took the snail 15 minutes, and it only took the ant 3 minutes. But let's go ahead and figure this out. For the ant, we're going to have to do it by hand. The antiderivative is t squared plus ct, evaluated from 12 to 15. But for the snail, we actually know that it's going to be 76.043. Okay, our goal is to solve for c. So 15 squared plus 15c minus 12 squared plus 12c equals 76.043. This is 225 plus 15c minus 144 minus 12c. Then we're going to get 3c plus 81, which equals 76.043. 3c equals negative 4.957. And you have your calculator for this, right? So use it. Negative 1.652. That's the missing c for the ant's velocity. So now I can take it and finish my equation. So the velocity of the ant is 2t minus 1.652. Now the question is saying the ant's velocity at 12 is b. Find b. So now all I got to do is plug in the 12, which is 24 minus 1.652. So this is going to be 22.348. The ant has a velocity of 22.348 inches per minute at t is equal to 12 minutes. And I think what makes this the hardest thing is that you have a lot of moving parts and you have to make sense of this setup right here. That they technically both have the same distance traveled. It just takes the ant a lot less time, right? Because the ant arrives at the snail's starting point at 12 minutes. So set up your integrals, work it out. Oh, and you also have to figure out a partial equation for the velocity for the ant. Okay, but that right there covers the first two questions of the FRQ. And next time I'll do part B without a calculator. Thank you very much.